All right, so this is the final video for chapter 10. This is called Select an Appropriate Display. So we're going to begin by creating a box and whisker plot. Now, this is not the example from your notes. I'm showing you how to do this. You are going to have to practice your own example for the one that is in your notes. So just pay attention. You can do this on a spare sheet of scratch paper if you want, but this is not the one from your notes, okay? First thing you're going to notice, my data is in least to greatest order. That's very important here. So your first step will be to put your data in least to greatest order. After you do that, you're going to find what's called the 5-number summary. These are the 5 important numbers that are used to help us create our box and whisker plot. We will start with the minimum because that's very easy to find. The minimum is 10, and the maximum is the other easy one to find. That's 35. Now, the next thing we're going to find is called the median. The median is the middle number when our data is in order. That's why it's so important for our numbers to be listed from least to greatest order. So our middle number is 21. If you don't trust me, go ahead and count it out. That's our middle number. That's my median. The median is also sometimes referred to as quartile 2. So sometimes you'll see a Q2 in place of the median. Since my median is a part of the set, I'm going to cross it off. And now I have broken my set into a lower half and an upper half. The next number we're going to find is called the quartile 1, or the first quartile, or the lower quartile. All kinds of different names used for this data point. The first quartile is the median of the lower half of the data. So we've got 4 numbers here. That means we have 2 middle numbers. I'm going to add them together. That's 27. And divide by 2. That's 13 and 5/10. That's quartile 1. Last but not least, we're going to find quartile 3. That's the median of the upper half of the data. Again, we have 2 middle numbers. If I add them together, I get 59. Divide that by 2, and I get 29 and 5/10. Again, third quartile is also sometimes called the upper quartile. Okay, so a lot of different terminology here. Now, when we plot these 5 numbers, the minimum is going to be plotted as a dot, and so is the maximum. Okay, so let me number my number line here. I'm going to count by 5s. That's 10, 15, 20, 25, 30, 35, 40, and 45. So my minimum and maximum are going to be plotted as dots, and they hover above the number line. My maximum is going to be a dot hovering above the number line. The 3 quartiles here in the middle, we're going to plot those as vertical lines. You'll see why in just a second. So quartile 1 is 13.5. That's somewhere around here. There's my line. The median is 21, and the upper quartile is 29 and 5/10. So now I have my 3 vertical lines. I'm going to connect them. There's my box. The name is Box and Whisker Plot. And my whiskers come from the edges of the first and third quartile to the min and the max. Okay, there's my box and whisker plot. Let's do one more box and whisker plot because there's something else that might happen. Remember, if there's only one median, if it is a number in the set of data, we cross it off, and that gets us our 2 lower and upper sets of data. This time we're going to see what happens if we have 2 middle numbers. So again, put your data in least to greatest order. The minimum is 45. Maximum is 76. The median is what we find next. The median here is going to be, we're going to find that using our 2 middle numbers, 51 and 59. If I add them together, I get 110. Divide that by 2, and I get 55. Now, in my last example, my median was a number in this set, so I crossed it off. In this example, your median is 2 different numbers, So you're going to draw a line between them. We're not crossing anything off this time. Draw a line between them. That gets you your lower half and your upper half. Okay, quartile 1, the median of the lower half is that number right here, 48. And quartile 3 is the median of the upper half. That is 60. So nothing got crossed off if there are two middle numbers. Remember that. All right, so now I go ahead and plot it. Remember when I plot these, the minimum and the maximum get plotted as dots, and the three quartiles get plotted as vertical lines. So let me number this quickly. 40, 50, I'm going to skip them in between, do this quickly. 60, 70, so this would be 45, 55, 65, 75. All right, so 45 is going to be right here. 48 is about there. 55, 60, and 76. Connect your box. Connect your whiskers. And there you go. Box and whisker plots, they show measures of variation or distribution for each set of data. They're useful for very, very large sets of data because they break them down into these 5 important numbers here. And something else for you to remember is that each chunk of your graph, let me change colors here. Each chunk of your graph, each quartile represents 25% of the data. So there's 25% there, 25% here, 25% in this section, and 25% in this whisker. So it shows where there are close together groups of data and where there are more spread out groups of data. So that is what a box and whisker plot is good for. Okay, the rest of these we're just going to go through quickly. This is a bar graph. Bar graphs, they show the number of items in each specific category. So that just breaks it into like different sections for us. 35 apples, 30 oranges, 10 bananas, 25 kiwis, 40 blueberries, and 5 grapes. So these are the number of people that think each fruit is nicest. A pie chart or a circle graph, these are known for taking a big group of people and breaking their interests or breaking the group into different parts or different categories. So it compares parts of the data to the whole set. So 20% of this group like sci-fi movies, 5% like drama, 6%, 30% like romance, 25% like action, and 20% like comedy. So that's how pie graphs, pie charts or circle graphs work. Next we have a double bar graph. So similar to our bar graph, this is the same type of thing, but now we are comparing 2 different sets of data. This we use color to distinguish between the 2 different sets. You can see that blue is first grade and orange is second grade. Next we have a histogram. Histograms are different from bar graphs because there are no gaps between the bars. So take a look at my bar graph, see the gaps between it. Histogram, there are no gaps. Another thing is that histograms have continuous data, which means these numbers down here are intervals. If you do not fit into one category, you probably spill into the next category, or the next one, or the next one, or the next one. There's no gaps because there are no numbers between 149.999 and 150. Line graphs show change over a period of time. So here we could see how the number of muffins sold changes each day. And last but not least, we have line plots. Line plots show frequency of data within number lines. So each X would represent one student and how often they studied. So you can use this to help you match your graphs in the bottom section of your notes. So all you should have to do to finish up your notes is that one example of a box and whisker plot, and you should be good to go. Start studying for Chapter 10, either for your upcoming test, quiz, or project.